Evangelista Torricelli's barometer worked like this. He had a big bathtub, basically, of water in his basement. And then a big, giant column of glass sticking up 30-plus feet. It was actually sticking out of the roof of his house. And if you walked by on a high-pressure day, then the water level would be a lot higher. If you walked by on a low-pressure day, the water pressure would be a lot lower. And, of course, that must mean that he is evil, because he's somehow magically manipulating the water level without doing anything. But what's really happening is on a high-pressure day, there are more air particles in that location. There's more pressure pushing on that location. And that pressure gets exerted on the bathtub full of water here, and it pushes the water up higher because the bottom is empty and the top is closed off. And if it's a low pressure day, it's not pushing as hard on the water, and so the water level would come down. And after a while, he really did get in a lot of trouble. I mean, they were, the Catholic Church was on him. They really thought that he was doing something evil, even after he explained it to him. So then he decided to use a different liquid. He changed to the Mercury Barometer. The Mercury Barometer could be built, same concept, a pool of mercury, a glass tube that's closed at the top. Maybe think of a test tube turned upside down. And this one was about 35 inches tall, so he could keep it in his living room. Nobody saw it as they walked by his house, and he survived. But what he invents in 1643 is the ability to measure air pressure. To measure air pressure. And this really has a huge impact on a lot of chemical experiments and reactions. So he kind of jumps us forward a little bit. The other barometer that sometimes people use is not actually a barometer. It's called a manometer. And what you do is you have a gas in a bulb. And these gases, this is the bulb right here. And the bulb could be filled with any one of a number of gases. And by heating it up or cooling it down, it's going to expand or contract. And it would push on this mercury. And so we're not going to use a manometer in here because you usually use mercury, and we're not allowed to have mercury. But if you take like a physical chemistry class in college, you'll probably use a real manometer filled with mercury. And most of the manometers they use are open manometers. So one end of the manometer is open to the atmosphere. What would happen if you overheated this gas? It would overflow. That gas would expand. That gas would expand and push the mercury right out of that, right out of the open end of the manometer. It's a real possibility. Oh, one last thing about Torricelli. He was a student and friend of Galileo's, which is the other reason he was under so much pressure, because the Catholic Church wasn't a big fan of Galileo either. All right. The only problem with studying gases is there's a lot of different units, and I'm sorry, but this is just one of those things. People now measure pressure chemistry-wise in atmospheres. So a standard day is 1 atmosphere of pressure. A high-pressure day might be like 1.05 or 1.1 atmospheres of pressure. But there's still a lot of other methods out there. There is 760 millimeters of mercury. That's one common method of measuring it, by having actual columns of mercury and measuring it that way, which is the way Torricelli was measuring it. Some people don't like to say millimeters of mercury, so they started converting that into torr. Why torr? It's named after Torricelli. It's named after Torricelli because he was measuring the height of the mercury, so they just started naming it after him. And then we have pascals. Have you ever heard of pascals? What did Pascal work on? Triangles. The 3, 4, 5 triangles and all those different triangles are called Pascal's triangles. Pascal was also very heavily involved in working with energy and working with gases. So he has his own constant for when you're working with energy or certain types of gases. This is a really large value, 101,325. Most people use it in kilopascals instead. And then there's PSI. What is PSI? Pounds per square inch. Yeah. It's the pounds of weight on a square inch. So 14.69 pounds is how much is pushing down on his head right now. So if I picked a square inch on his head, there's 14.5 pounds pushing down on him. Have you ever worn leg weights around the house? Yeah? What happens after a while? Your feet hurt? What happens when you take them off? You feel fast. You start walking around goofy because you don't have that weight on you. You are used to this 14.5 pounds pushing on your body, all over your body. And if that pressure somehow dropped off, you would have an extreme elation feeling. But at the same time, we'll talk about what would happen. We'll get into that as the pressure drops. I am going to ask you, and I know this is not going to be something you're very happy to hear, to memorize these guys. Whichever way works for you is the way you should do it. So you need to know those equivalencies. I'm going to ask you to do real simple conversions from one form of pressure to another form of pressure. So I set two up here. Why did I set them up the way I did, Jackie? Why did I set the 14.69 psi on the bottom? It cancels out the psi in the given. And then whatever I'm looking for goes on top, so those units are left behind. So for the first one, we have 28 psi times 760 torr divided by 14.69 psi, and I'm getting 1,450 torr. Same thing for the other one, except this time it's pascals. And this answer, you're expecting this answer to be gigantic, and this is 193,000 pascals, which is the same as 193 kilopascals, which is the more common, to convert 193,000 pascals into 193 kilopascals instead. So you'll have to be able to convert between those different units. There are actually a lot more units than these, because this concept of measuring pressure, once Torricelli's barometer got out there, moved worldwide, and there was all sorts of different units being used. A lot of these were created long before an international system was developed, because in 1649 there is no science governing body of all science. There's no IUPAC like there is now for chemistry. IUPAC is the International Union of Pure and Applied Chemistry. And they kind of govern all of the different rules of chemistry now. But back in 1649, that didn't exist. So there were dozens and dozens of different measurements going on, depending on which country you were in and what they already used. I could see in England they probably had one in terms of stones. How many stones of pressure was it? Because that was a common way for measuring weight.